A Ukrainian drone struck a 52-car Russian fuel train near Cherkovo.
At 02:43 hours on May 24, 2025, 3 Ukrainian strike drones cut silently through the darkness over occupied Zaporizhzhia Oblast, closing in on one of Russia's most critical logistics arteries. Below them, along the Verkhny-Tokmak-Melitopol railway line, an 8-car fuel train rolled steadily east, hauling roughly 560 tons of diesel, enough fuel to sustain 2 Russian battalions for an entire week. What the crew did not know was that in less than 60 seconds, that fuel would no longer be destined for armored vehicles. It would be burning across the Ukrainian countryside instead. This operation did not rely on a single weapon, but on coordination. 5 drones, each with a distinct role, working as a single system. A DJI Mavic 3 reconnaissance drone loitered 8 kilometers away, providing overwatch and target identification. 3 Ukrainian-built FPV quadcopters were assigned strike roles. A second DJI Mavic remained further back, held in reserve in case the primary reconnaissance platform was lost. These were not commercial drones in their original form. Ukrainian-modified Mavic reconnaissance platforms often feature extensive field upgrades, including altered firmware and additional sensors. The stock Hasselblad camera carries a 20-megapixel sensor with up to 28 times hybrid zoom, with experimental firmware reportedly extending digital zoom beyond 50 times. Some units have been retrofitted with FLIR boson thermal cores, allowing night reconnaissance and heat detection far beyond civilian capability. The reconnaissance drones cruise at roughly 68 kilometers per hour, with endurance approaching 46 minutes and operational ceilings up to 6,000 meters. The attack drones are something else entirely. These Ukrainian-built FPV quadcopters are optimized for one-way strike missions. 7-inch propellers driven by 2807 class brushless motors generate up to 2.5 kilograms of thrust each. Controlled by F7 flight controllers running custom Betaflight firmware, they can exceed 140 kilometers per hour in terminal dives while maintaining stability during impact. In modern warfare, few systems deliver this level of lethality for such low cost. 30 kilometers away, inside a hardened command center, Ukrainian operators monitored thermal feeds as a distinctive heat signature emerged against the cool night terrain. The Mavic's thermal sensor can detect temperature differences as small as 0.05 degrees Celsius at ranges up to 200 meters. Firmware modifications allow the drone to evade Russian aeroscope detection systems that normally track unencrypted DJI transmissions. Through encrypted channels, the lead reconnaissance operator confirmed visual contact. The locomotive's diesel engine glowed brightly on thermal imaging, an unmistakable beacon in the darkness. Target data streamed in real time to the strike operators. Each FPV drone carried a likely payload of roughly 2.6 kilograms, a dual-stage shaped charge warhead designed for one-time use. Hardened steel and tungsten alloy liners focus explosive energy into a high-velocity jet capable of penetrating more than 22 millimeters of hardened steel. Russian fuel tank cars typically use walls between 10 and 15 millimeters thick. Penetration was guaranteed. Once breached, ignition temperatures exceeding 2,500 degrees Celsius would do the rest. But explosives were only part of the equation. Timing mattered just as much. Ukrainian intelligence had tracked this specific train for 72 hours, using a network of partisan spotters equipped with nothing more than smartphones. They mapped its refueling schedule, average speed, and most importantly, the 15-minute window when it passed through a gap in Russian air defense coverage. These civilians, living under occupation and risking execution if discovered, provided the data that made this strike possible. With the target confirmed electronically and visually, the first strike operator initiated his attack run. His FPV quadcopter descended into a shallow dive toward the moving train. During most of the flight, the drone relied on encrypted GPS navigation. In the final 15 seconds, it switched to optical guidance. Image recognition algorithms locked onto the fuel car's shape and features, maximizing accuracy during terminal approach. The train moved at roughly 11 meters per second, leaving no margin for error. As the quadcopter accelerated, the operator made only micro corrections, keeping the drone's nose steady while the target filled more of the frame with every passing second. The fuel cars slid forward beneath the drone's path, their rounded silhouettes growing larger as rails, wheels, and coupling joints resolved into sharp detail. At this speed, there was no room for hesitation. Any late adjustment would send the drone past the target or into the ground. The system compensated automatically, smoothing out vibration, predicting motion, and narrowing its aim to a single impact point on the moving tanker. What looked calm on the operator's display was, in reality, a race against physics unfolding in real time. At 0244 hours, as the first strike drone entered its terminal dive, the Russians finally reacted. 3 kilometers away, a Russian Lear-3 electronic warfare system spun up. Mounted on a KAMAZ truck chassis, the system can disrupt drone control links and GPS signals across a 30-kilometer radius. The operators detected the commercial drone signature and began broadcasting powerful jamming signals across multiple frequency bands. The Ukrainian operator immediately reported heavy interference as his control interface flashed connectivity warnings. The Russian crew escalated quickly. Broadband jamming flooded multiple frequencies. When that failed, they switched to focused spot jamming on the 2.4 gigahertz band commonly used by commercial drones. But this scenario had been anticipated. Ukrainian drones in this sector employed frequency-hopping spread-spectrum techniques, switching channels hundreds of times per second across multiple bands. Both the reconnaissance and strike drones operated simultaneously across 3 frequency ranges, a configuration specifically designed for contested electromagnetic environments. As jamming intensified, the reconnaissance drone software automatically scanned for cleaner channels and shifted links without operator input. The attack drone's control system hopped to an L-band backup link. When Russian operators attempted GPS spoofing, injecting false satellite signals, the drone's inertial measurement unit detected inconsistencies between movement and positional data. Accelerometers and gyroscopes took over navigation instantly. GPS could be denied. Physics could not. As communications degraded, the attack drone transitioned into autonomous mode. Onboard target recognition software identified the fuel car's structural features, calculated an optimal impact point, and continued the attack without further human input. Russian electronic warfare had succeeded in disrupting a channel. It had failed to stop the weapon. At 0244 and 30 seconds, the first drone struck the third fuel tanker car. The shaped charge detonated on contact, the penetrator jet punching through the 12-millimeter steel wall before the secondary incendiary charge ignited the pressurized diesel inside. Hundreds of gallons vaporized instantly. A massive pressure wave ruptured the tank's internal structure. On thermal feed, the strike operator watched the heat bloom expand violently across the car as secondary explosions began cascading. The design of the train accelerated its destruction. Ventilation systems linking adjacent tank cars, intended to equalize pressure during loading, now served as conduits for flame. Within 15 seconds, vapors ignited in the second and fourth cars. The locomotive engineer applied emergency brakes. The train stopped, and in doing so, became an immobile target. At 0245 hours, with the initial strike fully engulfed, the remaining operators moved in. The second strike drone targeted the sixth car, approaching from the southeast, using smoke and fire as concealment. Thermal sensors locked onto the cooler metal signature of an intact tanker. The guidance computer compensated for heat distortion, maintaining accuracy despite deteriorating visibility. The shaped charge struck with identical effect, igniting another 69 tons of fuel. Simultaneously, the third operator approached from the west, targeting the eighth and final car. The impact followed the same brutal sequence: penetration, ignition, catastrophic combustion. Within seconds, 4 consecutive tank cars burned as a single inferno. Roughly 560 tons of fuel fed the blaze. The heat generated its own convection system, pulling air inward and driving a column of fire and smoke more than 200 meters into the night sky. The railway itself was finished. Steel rails warped into unusable shapes. Even without further strikes, this line would be offline for weeks, assuming repair crews could work under constant threat of repeat attacks, and every second of it was captured in 4K. Tap to watch for more.